Hi, and welcome to the second video in a series of 4 videos concerning the two optional projects for our class. These projects both use JavaScript, and they both use the P5JS library or framework, which is written in JavaScript. In the first video, I talked about where the data came from, how the weather data that we're going to work with were acquired by means of a program, and looked at the file to see what it looked like as comma separated values file. In this video, we're going to look at actually getting that data into P5JS and a little bit about how you would access the various rows in the CSV file from the P5JS program. The good news is you don't have to install anything to use P5JS because they have a really excellent web editor. That's what I'm going to be demonstrating, which lets you create your program, edit your program, and run your program in your browser all on the web. So let me share my screen and I'll show you, and we'll walk through this P5JS program. Okay, you should see on your screen a black window. I got it dark mode. It's very configurable. If you don't like dark mode, you can fix it into light mode if you want. And this shows you the basic of the program. So this is an editor. This lets you edit the program. So you can type in code, you can change code, you can run code, and you can debug code all on this web page. You can, if you create a free account, which I have done on the p5js.org website, you can even save your work in their cloud, which is very convenient. And that's what I've done here. And when I give you a starter sketch to help you get started with the subsequent projects, you can start from something I've already saved in the cloud and then add your own enhancements, completions, and embellishments. This program is in JavaScript. So we're transitioning now from Python to JavaScript. I think that will be a relatively easy transition for many folks because JavaScript, you will find, looks rather more like most other languages than does Python. JavaScript looks like the C family of languages, C, C++, Java, PHP, many others. It uses braces, it uses parens and ifs. Syntactically, it looks very, very similar, which helps. Comments are the same way. So I don't think you'll have too much trouble following along. One of the things that's different from other programming languages, but probably not from Python, is that variables in JavaScript are not typed. That is, you can use a variable to hold a number, or you can use a variable of the same name to hold a string. So when you see me declaring variables, you'll see that I may or may not give them an initial value, depending on how I'm going to use them. So here's how the pane at the left shows you all the files that make up a P5JS web application. We're looking at sketch.js. Well, that's the JavaScript code. There's also an index.html, which basically tells the browser how to load the JavaScript or where to load it from and any additional files that it needs to load. So if you had one of our HTML classes, you're going to find this stuff is very familiar. And the only thing that may be different from what you've done before is this script tag, which points to the JS or JavaScript file that we've loaded. The style sheet, I don't know much about CSS. I don't know anything about CSS. If you wish to play with a style sheet, please feel free. And last but not least is this file, the CSV file we loaded, which is the file that has all the weather data in it. So when you clone or duplicate my sketch to start your sketch, your web application, you'll get a copy of the data automatically. But if you ever need to upload the data, all you really have to do is go here, go to sketch files, go to upload file, and you can upload a data file from your PC or Mac to the P5JS environment. So, okay. Let's look at sketch.js and let's walk through what it does. These variables here that begin with let, that looks a little weird if you haven't seen it before. It's basically, these are global variables. So they're visible in every function that's in this same JavaScript module. The let is actually an ancient term. It comes from basic. Basic had all of its assignment statements prefixed with the word let x equal 5. It looks weird to see it now, many years later, but that's basically what happens in JavaScript. There are 3 functions that you need in almost every P5.js program. The first one you see here on line 10 through 12, that's called preload. And what that does is that function is run at the very first before any other code is run. That's where you need to put operations that might take a long time. Now, reading in that weather.csv file takes several seconds. And of course, that's an eternity in computer time. If you did not do that in preload, the rest of your sketch would start running before the data finished loading, because JavaScript is asynchronous. Things happen and they don't block. And of course, something bad would happen later on when you tried to access data that had not yet been loaded. By putting it in preload, we make the whole program come to a screeching halt until the data is loaded. Once it's loaded into memory, the program runs at full speed. This load table, which all of the JavaScript, all the items in P5.js you see here, you can of course find in the P5.js reference page. And this method, load table, is actually kind of cool. It opens this file. Here's the name of the file. We have to tell it's a CSV file, so it knows to look for commas. And we need to tell it has a header. Remember the first row of our CSV file had column names? That's what tells P5.js to get those column names and remember them. A table in P5.js is basically the same thing as if you imagine a Python list of dictionaries. So if you imagine that you have a list or an array, and each element in that array is a dictionary where the keyword, the key, is the name of the column and the value is the value of that column, that's what you'd have. But instead, of course, having to set that up, define that all manually, the table that's returned from load table is already configured to do that. So all the data are read in and the table knows the names of all the columns. It gives you methods, accessors, that let you get each column and each row. So that's preload. Setup is a function from line 16 to 25. This is run once and only once, after preload, but before draw. So this is where you put any one-time setup code in your program that doesn't take a long time. And for example, one is just, let's figure out how many rows we loaded. So we'll ask the table, how many rows did you count? And it turns out it's a lot. Console.log does what print does, basically. In Python, it throws a message out where you can see it textually. And create canvas, which is not currently used in this program, but you will need in your programs, actually opens up a drawing canvas so that when you use graphical methods, that they actually will appear in a window. So that's all we're doing is setup. We're just counting the number of rows, we're printing the number of rows, and we're getting set up. The real meat of this function is all in draw, which begins on line 27. This function is run over and over and over again. It's already in an endless loop somewhere. So if you imagine a loop that says while 1 draw, that's what's happening. So each iteration of draw in our program here is going to process 1 row of data. So there are so many samples here, as you'll see, that I've elected to narrow it down a little bit by skipping to every 5 samples. So we're just skipping some data, which makes the program run more quickly. You're welcome to tinker with that value as you please. If you set it to 1 plus equals 1 to increment by 1, you'll get every data row. Once we know which row we want, that's sample num, we can ask the table to give us that row and the numeric value of the column named temp for temperature. So it's going to go row 0, 1, 2, 0, 4, 9, because I'm skipping by 5. And each time it's going to get the value of the temp column, which if you recall was the second column over, I think. You don't need to know that because it's got a name. That's a temperature in Celsius. And since, like most Americans, I'm totally lost in Celsius, I convert that here to Fahrenheit. That's purely optional, but that makes it easier for me to understand. Also, we can get the date and time that corresponds to that sample from the file. Just go back into the table for the same row and get the value of the column called date time. And then I've added this code here, which you don't need currently, but if you do want to track how much time has elapsed, this technique of kind of remembering the previous value is useful. And finally, at the bottom of draw, we print out the date and we print out the temperature from the file in degrees Fahrenheit. Let's run this and see what it looks like. As you can see, data are scrolling by and you see the date and time. The time is actually in UTC, which is used to be called Greenwich Mean Time. In other words, it's 4 or 5 hours different from our current time. And the value to the right, with a variable number of decimal places, is the temperature in Fahrenheit. So this is going to go on for a long time, because if we scroll back and look at the very beginning of this data, these data, it's a long way back already. I don't see it. I don't see it now, but it scrolled off. But there were 147,000 rows. I think in the earlier video, I mistakenly said, oh, it's a big data file. It's got 6,000 rows. No, it's a really big data file and it has 147,000 rows. So this would go on for a long time. In the subsequent projects, what you will do is take these data and either visualize them as a graph, specialized graph over here in the this pane, or actually play them as audio, which is a little bit weird, but interesting. This is a full featured editor. You can copy, paste, cut. Obviously, it's syntax colors, and you can save your file by selecting File Save, and this will save your file in the cloud, assuming you've created a free account. If you don't create a free account, and I strongly recommend you do that, all you have to do is give an email. They won't spam you with an email. This is the Processing Foundation who runs this is a 501c charitable organization, and they're not out to get any money from you. But if you don't, I think you have to copy and paste your files to download them. So it's best to open that account and using any email you like. And then you can simply save your files in the cloud, which is very, very convenient, especially if you work on multiple machines. So that's the basis. There's a lot more features to this editor, which I'm not going to go into here, but this will be enough to let you get started. So you'll start from this sketch and make sure it runs. And then you can start embellishing this to make one of the two upcoming projects, either the visualization or the audio. And I'll see you in the next video.